Okay, let's just jump right into this explainer. Today, we're cracking open the structural DNA that 10 wildly different production-ready AI systems all actually share. We're looking at the core playbook used not just to pass those brutal AI system design interviews, but more importantly, to build reliable systems out in the real world. Because, if you've been working with AI lately, making it work in a nice, controlled environment is one thing, but deploying it to actual users, that's a completely different beast.
So you really have to wonder, why is it that an AI can look absolutely flawless on demo day, but then completely fall apart when real users get their hands on it? We've all seen the headlines. Take Klarna, for example. In its first month, their AI was doing the work of roughly 700 full-time agents. It handled millions of conversations, saved a massive amount of money, but then they had to dial it back and actually rehire humans. Why? Because the automation just went too far. It proves that while massive deflection is totally real and valuable, having a human-in-the-loop escalation path is absolutely not optional. Automation without perfect safety is just a recipe for spectacular failure.
And honestly, this brings us to our core villain in system design, the model's non-determinism. Think about traditional software. You put the exact same input in, you get the exact same output out. Easy, right? But a generative model doesn't do that. It doesn't return the same thing every time, and worse, it can be confidently wrong. Because of this one single fact, building AI requires a completely new playbook. You need a really rigorous master pattern to basically tame that non-determinism, ensuring your system fails safely instead of, causing a total disaster. So here is our roadmap to taming that villain today. We'll start with the 5-layer master pattern. Then we'll see why evaluation has to sit right at the center of your design. After that, we'll unpack the wrapping layer, identify a really dangerous concept called the lethal trifecta, and wrap up with optimization and production. Okay, starting with part 1, the 5-layer master pattern. Let's build our defense layer by layer. Down at the very base, we've got layer 1, which is the model itself. This is your non-deterministic engine. Now, it's the brain, sure, but a really common mistake is thinking the model is the system. Most of the interview, and frankly, most of your day-to-day design work, doesn't actually live here. You simply pick a model that clears the bar for your specific task, and then you handle its ambiguity downstream. You do that using structured outputs, forcing the AI to reply in highly predictable formats, and through smart routing. Moving one step up, we hit layer 2, the wrapping layer. This right here is where the vast majority of your architectural design actually lives. You're wrapping that foundational model in 3 distinct things. Knowledge, which is usually retrieval over your own private data. Tools, which act as the AI's hands. And memory. And here's the secret. If you change the balance of these 3 elements, you fundamentally change the entire behavior of the system. Now, here is the absolute game changer. Layer 3, evals and guardrails. This layer exists entirely as a consequence of using a non-deterministic model. In traditional software, testing is basically a final gate before you ship, right? But in AI system design, evaluation is the very center of the architecture. It acts as the release gate to catch any silent degradation in the model, and it provides the real-time, runtime guardrails that keep a toxic or hallucinated generation from ever reaching your user. Next up is layer 4, and this is where reality hits: production and ops. This covers the messy reality of running this thing in the wild. We're talking serving scale, managing incredibly strict latency budgets, and ensuring deep observability. You need to be able to see exactly what happened under the hood, meaning every single tool call and model generation must be a fully traceable span. If something breaks, you better have a clear rollback plan ready to go. Finally, sitting way up at the top, we have layer 5 optimization. This includes the fancy stuff like caching and complex routing. Notice that this is kept deliberately at the top of the stack, because once the system actually works and you can accurately measure it, then you go in and make it faster and cheaper. All right, let's zoom in on our second topic, putting evaluation right at the center. Because what we define as accurate changes entirely when we move to AI. Look at this real number from Tau to Bench, which is a standard industry benchmark. A single try accuracy rate of 61% on a coding agent might look perfectly acceptable on demo day. I mean, you run it once, it spits out the right code, and everybody claps. But what happens when that exact same agent has to succeed on a sequence of independent actions to actually resolve a real customer's issue? Well, that completely exposes the unforgiving reality of what's called pass to the K reliability. That 61% single try pass rate, it can literally collapse to about 25% across just 8 independent tries. Think about it. An agent that succeeds on average but totally fails 1 out of every 4 tries simply cannot ship.
Imagine a customer support agent handling real financial refunds, making a mistake 25% of the time. That's a disaster. Reliability across repeated runs, that pass to the K metric, is the true shippable bar, way above just average single-shot accuracy. Moving right along to Section 3, let's unpack that wrapping layer, where we give our AI tools to interact with the world and manage its memory.
Now, memory isn't just about carelessly dumping a massive chat history into your prompt's context window. It's a super strict budget, and it's broken down into 3 tiers. First, you have short-term memory, which is literally just the current session. Second, working memory, which holds the active, retrieved task context. And third, long-term memory, like a user's baseline profile. Crucially, long-term memory is retrieved only on demand. You never stuff it wholesale into the prompt. And here is the golden rule you have to remember. You must always treat memory as completely untrusted. Anything persisted from a user or an external document could easily smuggle a malicious injected instruction right into a later turn.
But it's not just about memory. We also have to give the AI hands, which means tools. These tools operate inside the React loop, where the model is prompted to reason, act, and observe. The principle of least privilege is absolutely critical here. For instance, an order lookup tool, that's just a read action. It has a super low blast radius, so it's cheap to trust. Let the AI use it. But an issue refund tool, that is a high-impact write action. That demands an explicit human gate. You literally never give the AI open-ended code execution in production. You give it typed, allow-listed contracts, and you put a hard cap on exactly how many steps it can take.
Okay, Section 4. This is about knowing exactly how to shield your system from its single biggest vulnerability. We call this vulnerability the lethal trifecta. Look, any 2 of these conditions are usually manageable. But if you combine untrusted content, like a random external web page or an unverified user prompt, with access to your private data and the ability to autonomously act or communicate, you've just created a massive security hole. Imagine a poisoned shared document that quietly instructs the agent to secretly email your private data out to a hacker. Because reading untrusted content over private data is often the whole point of the AI product, you usually can't remove those first 2 pillars. So you have to manage the third. You must keep the system read-only by default and heavily gate every single action that writes or communicates externally. So how do we fight that? We defeat this danger with 2 totally distinct shields that do very different jobs. Online guardrails are your real-time defense. They have to be lightning fast, blocking bad outputs instantly, checking for PII leaks, or immediately triggering a human escalation the second the model's confidence drops below your set floor. On the other hand, the improvement flywheel runs offline. It's a batch process used to track long-term accuracy trends, test recall in sampled sets, and monitor baseline drift over time. The guardrails handle the immediate disasters, while the flywheel makes the entire system smarter over the long haul. Which brings us to our final section, optimization and production. Let's clear up a major industry misconception that trips up so many developers right now. Look, we've all heard the massive hype around multi-agent systems. But as this quote perfectly captures, multi-agent orchestration belongs strictly in layer 5. It is a careful optimization, guys, not a starting point. Reaching for multi-agent architectures too early is literally one of the most common ways a system design gets overly complex, practically impossible to evaluate, and ultimately just worse. The big takeaway here? You have to earn agency through evaluation. Every single time you want to increase autonomy in your system, it must be paid for with a hard evaluation that proves it actually helped. You only add complexity, like spinning up a second agent, when your baseline single-agent system is provably maxed out, correctly measured, and its current limits are exactly what's bottlenecking your performance. Keep it simple until you absolutely can't anymore. So I'm going to leave you with this question. Looking at your own projects, do you actually have a rigorous 5-layer architecture in place to catch these failure modes? Or are you just heavily relying on prompt engineering and hoping for the best? Because as we've seen, hope is not a production strategy. You need structured outputs, bounded tools, real relevance floors, and rigorous evals right at the center of your design. Thanks for hanging out with me for this explainer, and I seriously challenge you to start applying this universal playbook the very next time you build.